Hello, today is your day that you can fill in that last section on that purple exponent rules. We're going to learn about what rational exponents are. But to start out with, if we can start with a warm-up. Yesterday we talked about simplifying radicals, and I also have another practice with simplifying with negative exponents. So pause the video and take a few minutes to try both of these, see where you're at. And when you're ready to see the answers, after you've tried them, hit play. So go. All right, so hopefully you tried those and you're ready to see how we do them. All right, so yesterday we talked about simplifying roots. And when it's a cube root or any type of root, we talked about those prime factorization trees because you'd have to think about what's the biggest perfect cube that goes into 40, which might not be easy to do, but the prime factorization trees aren't too bad. If I can get this to show up a little better here. Okay, so something that goes into 40, you might have said 5 and 8. And I told you 8, if you're used to that being 2, 2, and 2, you can kind of cheat and go that route. All right, and we did this two ways. So I'll do the long way, where you list out all the prime factors, so 2 times 2 times 2 times 5, and then also all the letters, so 7 S's, 10 R's, and 5 T's. All right, and then since it's a cube root, what are you looking for? Groups of 3. So there's 3 2's, so we'll get a 2 out front for sure. Now for the S's, you can count how many groups of 3. The shortcut was what you do with the 7 and the 3. You divided them. So 7 divided by 3, 3 goes into 7 twice. So there should be 2 groups with 1 left over. Let's see. We've got 2 groups with 1 left over, exactly. So we're going to have 2 S's come out, so that's S squared. Do the same thing with R's. If I divide by 3, how many groups am I going to have? 3 with 1 left over. And you can see there's a group of 3, there's a group of 3, and there's a group of 3, 1 left over. So we'll have R cubed. And how many groups of T's? Divide by 3, it only goes in once, but there'll be 2 left over this time. So 1 T out front. And then underneath the root still, we still have a 5, we have an S, we have an R, and we have 2 T's, so T squared. And don't forget that cube root. So just kind of writing that a little bit nicer. Come up here. Final answer would be 2 S squared R cubed T times the cube root, remember that 3 there, of 5 SRT squared. And there's your answer. All good? Great. All right, part B, simplify and write using only positive exponents. So this was from the first couple days. Is there anything that needs to be distributed? Nope. Anything to deal with negative exponents? Yup. And what are you going to circle? Hopefully you circled the x cubed and the x to the negative first and the y to the negative fourth, but not the 5 and the 2 because those both have exponents of 1 on them. Okay, so when we write what hasn't moved, we've still got the 5 and the y to the 6th on top. We've still got the 2 on the bottom because those weren't circled. What else is on top now? We have x to the first, y to the fourth, and the bottom we have x cubed. So I would simplify top and bottom. We really have 5x y to the 10th on the top. On the bottom, we've got that 2x cubed. And now, final step, is there any canceling we can do? Well, that x is going to go away with one of those, but there's still 2 x's on the bottom. And it looks like your final answer should be 5y to the 10th over 2x squared. All right, so depending on how you did on those two, will tell you where you're at in the unit. If you got both of those right, you're understanding everything. If you got them wrong, hopefully you understand where you went wrong. Here's your random fact of the day. Until the 19th century, solid blocks of tea were used as money in Siberia. All right, so you do need your own paper again, so you can pause the video if you need to get your notebook out. But when you're ready to go, you can call today Unit 10, Day 4. And we're going to call this rational exponents. So rational just means they're fractional, or they can at least be written as fractions. So I want to start by asking the question, how can you express the square root, or how can you express a square root using an exponent? So we spent a lot of time yesterday on simplifying square roots, but now I want to change them to write them as an exponent. Okay, so for my first example here, I'm going to say solve for m. I'm going to answer this question using some work. So let's say we had the square root of a is equal to a to what exponent? So it's kind of the math way of asking the question I wrote. I've got the square root of a. Instead of having that square root, I want an exponent instead. So one thing I could do is, if I want to get rid of the square root, what gets rid of a square root? Squaring it. So I could square both sides here. Then I would have a equals a to the, when you square, what do you do with the exponents? We know this. Multiply them. So that's 2m. Okay, well, that's really a to the first equals a to the 2m. All right, and this is something we haven't talked about yet this year, but if the bases are the same, by base I mean a in this case, so the bases are the same, so exponents must be equal. Like if you have a number raised to a power and that same number raised to a different power, the only way that's going to be true, because the bases are the same number, is if the exponents are also the same. So we can kind of drop the a's and just say, okay, well, 1 has to equal 2m. So that means m is 1/2 if I divide both sides by 2. So what did that show? That just showed, so the square root of a is equal to a to the 1/2 power. Okay, so that's how I express a square root as an exponent. The square root means the same as the 1/2 exponent. Let's try another one. I'm going to say solve for m again. So I'm going to use a cube root. Let's say the cube root of a is equal to a to the m. So instead of writing the cube root of a, I want to write a to some exponent, so we got to figure out what m is. So what undoes a cube root? Well, just like I squared both sides last time, I'm going to cube both sides this time. So that leaves me with just a over here equals a to the 3m. Okay, just like last time, this is really a to the first, right? And if the bases are the same, what can I do? I can say 1 has to equal 3m. Divide by m, or divide by 3, and you're going to get that m is 1/3. So the cube root of a was equal to a to the m is 1/3. So if you look at both of those, maybe you can see a pattern. Square root is the 1/2, cube root is the 1/3. What do you think fourth root would be? It is 1/4, and so on and so on. Let's do one more, and then we'll summarize. One more solve for m. This time I want to do the square root of a cubed equals a to what power? A to the m. Well, I just saw that the square root was the 1/2 power, but how's that cube going to affect it? Well, get rid of the square root, so square both sides. So a cubed equals a to the 2m. Bases are the same, so the only way this is true is if 3 is equal to 2m. And if I want to solve for m, I get 3/2. So in this case, the square root of a cubed ended up being a to the 3/2 power, because that's what m came out to be. All right, so with that last one, you can kind of see the full picture. The type of root is what's going to be in the denominator of your exponent. When it was a cube root, it was a 3. When it's a square root, it's a 2. I told you if it was a fourth root, it'd be a 1/4 on the bottom. And the power that's on, in this case, the thing inside the radical, but it could be outside the radical also, is the power on the exponent, the numerator on the exponent, the 3. With all these, the power was 1, so that's why it was 1/3 in all of these. All right, so I'm going to start a clean page and summarize this. So, summary. Big idea for the day. For any natural number n, natural numbers are like the counting numbers, 1, 2, 3, 4, 5, things like that. Any integer m, integers can be positive, negative, or 0, and real number a, so that means it can be at any decimal, basically anything that's not an imaginary number. Then the nth root of a to the m is always going to equal that base. Remember, the root is the denominator of the exponent, so n would be in the bottom. The power is the numerator. So the nth root of a to the m is equal to a to the m over n power. And if you look at the examples that we did, it follows that rule. Or it actually doesn't matter where this exponent is. It could be on the outside of the radical also. So if you see something like the nth root of a all raised to the m power like that, that's actually the exact same thing. And I'm not going to prove why, but it does come out to be the same thing. It's a pretty easy proof. So the stupid way to remember this is a caret. If you've got a caret, there's my caret. The bottom of the caret, the part that grows below the ground, is the root of the caret, just like the bottom of the rational exponent is the root of the radical. And here's where it's stupid. The top of the caret, that leafy part, grows from the power of the sun. So that means that the top of the rational exponent is the power that was on the original expression, the m power. So remember the caret. It should be stupid, and that should help you to remember it. Okay, so we've got kind of two ways to try these. First example, and this is, I think, how the directions in your homework read also. Translate each expression into an expression with radicals. Simplify numerical expressions when possible. If it's all numbers, we're going to simplify. And the first one I'm going to start with is negative 125 raised to the 4/3 power. Okay, so the first part of this said to translate into an expression with radicals. Before I do that, let's go back and look at this real quick. Why did they have all these different types of numbers? Let's check. It said natural number n, so the denominator has to be a natural number. It has to be 1, 2, 3, 4, 5. So I'm just saying that that can't be a decimal or a fraction. And since it's natural, it also can't be negative, can't be 0, because you can have 0 on the bottom of a fraction anyways. So that's why they said natural number here. They're letting m be integers, so they are allowing zeros, because you can have 0 on the top of a fraction. You're not usually going to have a 0 power, but you could. And it's also allowing negatives, because you can have negative exponents. So that's why those are integers. And real number a, they're not really putting any restrictions on the base. The base can be anything. We can raise any type of number to any power. Okay, so that's for that. Not super important, but I just wanted to mention it. Okay, so if I want to translate this into an expression with radicals, this is the same as saying the what root. So it's the third root, because that's the thing on the bottom. So the bottom of the exponent is the root, the cube root of negative 125. And then the exponent is the 4. Now again, that exponent can go inside or outside. Putting the 4 right here, do you know negative 125th to the 4th power off the top of your head? I definitely don't. So I think it's easier a lot of times to put that on the outside. So that's an expression with radicals. Now, since it's a numerical expression, there's no x's or y's or any variables, we can simplify this. So work in the parentheses first. What's the cube root of negative 125? Well, you could do a factor tree if you really needed to, but 125 is one of those cube roots that a lot of people know already. And since it's negative, remember from yesterday, the cube root of a negative is what? Not I, that's the square root of a negative. The cube root of a negative is just negative. So this is going to be negative 5 raised to the 4th. And if you don't know that, you can plug that into your calculator at this point. But negative 5 to the 4th, so negative 5 times negative 5 is 25, times negative 5 again is negative 125. If I multiply that by negative 5, you'll get positive 625. Now, fortunately, your calculator is smart enough to do rational exponents. If I did parentheses negative 125 raised to the 4/3 power, oops, I've got this old calculator. Since it didn't go up in the exponent, I need to put the exponent in parentheses also. Most of you have those, like it'll go up in an exponent when you raise that, so you won't need to do the parentheses. But if I raise this to the 4/3 in parentheses, there's that 625. So the calculator can evaluate when it's all numbers. Okay, let's try another one. Let's do x to the 11/8. Well, this is pretty straightforward. Think of the bottom. The bottom is the root, because that's the caret, the root of the caret. So it'd be the what root? The 8th root of x. The top is the power, the 11th. That's not a number, so that'd be my answer. Now, just as a side note, you could have written the 8th root of x to the 11th and been totally correct as well. So either way is fine. Okay, let's try this one. Let's say 125 to the negative 4/3. So kind of similar to part A, but I changed where the negative was. It's in the exponent now. So remember, what does a negative exponent mean? It means to flip the side of the fraction it's on. It doesn't mean to flip the exponent. So technically the 125, the negative 4/3 is in the numerator right now. If I want to flip it, I can make it 1 over 125. And now what's the exponent? Positive 4/3. So again, you flip the side of the fraction that it's on, but you don't flip the exponent. So don't fall into that trap. Don't flip exponent. And then from there, you should be able to evaluate it. This is the same as saying 1 over the what root? The third root of 125 raised to the fourth. We did that before. Which is going to be 1 over 5 to the fourth, cube root of 125. And we know that from the last one is 625. So 1 over 625. And the calculator would be smart enough to do that as well if you wanted to. Okay, here's example D. Let's do a fraction, 81 over 16, all raised to the 3/4. Okay, so you can have a fraction under a radical, that's totally fine. So what type of root is this going to be? It's going to be the fourth root of 81/16, and the end will cube it because of that 3 up here. Okay, now it's all numbers, so we need to evaluate it. You might not be great with fourth roots, so if you're not, you can do your factor trees. So 81 is 9 times 9, and both of those break up into 3 times 3. Just like 16 is 4 times 4. Both of those break up into 2 times 2. So if you really wanted to reduce this, maybe you already are seeing what's going to happen. We've got 4 3's on top. We've got 4 2's on the bottom. All that cubed. And since I'm learning the fourth root, if I wanted to simplify this, what types of groups would I be looking for? I'd be looking for groups of 4. So conveniently, there's 4 on both. So a 3 is going to come out on top. A 2 is going to come out on the bottom. There's nothing left under the root anymore. So we just have 3 halves cubed. And the final answer would be cube the top, cube the bottom. It's like we're distributing the exponents if you want to think of it that way. So 3 cubed over 2 cubed is 27 over 8. All right, so first step, not too bad. That's the new part. The rest of it's kind of just review. All right, let's do one final one, and then we'll switch the directions up. What if I had xy all raised to the 5/3? Now, if you wanted to, you could distribute these exponents. But since they're both 1, we could also just make this one giant radical. What type of radical would it need to be? It'd be the cube root of xy. And then what power would we be raising that to in the end? To the 5th. Now remember, this is also the same as saying the cube root of xy to the 5th with that 5 in the radical. And in this case, that might be a little bit easier to deal with because then this just means the cube root of x to the 5th, y to the 5th, which is like something we did yesterday. So that's why it's good to know both ways to write it. When it's a number, it's easier just to deal with that extra power at the end. But when it's variables, you might want to deal with them earlier. Because this is the cube root of 5x's and 5y's. I know a bunch of you could probably have done this without drawing it all out, but we're looking for groups of what? 3. So my final answer, we're going to have an x out front and a y out front. And then we still have the cube root, remember that 3, of x squared, y squared. And that's it. All right. Any questions on this page? It's a little tricky, but if you follow those steps, you should be able to do the homework okay. I got one more type to show you. So I'm going to flip to a new page again. Here we go. The other type of question you'll see in the homework, the directions say something like this. Translate, basically going the other way. Translate each radical expression into exponents with into expressions with rational exponents. And I'm going to also say simplify. So if you can, simplify as much as you can. Now, a lot of times these would be multiple choice questions. That's where I usually see them show up on tests. We'll start easy. The 5th root of y to the 4th. And when you're doing these, remember the caret. The bottom of the caret's the root. The top grows from the power from the sun. So if I want to translate this into an expression with rational exponent, y is my base. The exponent, the root is 5, so that needs to go on the bottom. The power is 4. That's it. Y to the 4/5. Ease peas. Next one. Let's do the 4th root. We'll do a number this time of 1296 raised to the 3rd. So translating that into an expression with rational exponents shouldn't be too bad. The base is 1296. 4 is the root, so that's going to go on the bottom. 3 is the power, so that's going to go on the top. So it's the 3/4 power. So there's your expression with rational exponents. That one we can simplify, and I wouldn't expect you to be able to do that in your head. Luckily, the calculator, you can just type 1296 raised to the, I need parentheses, you shouldn't, 3/4 power. It's 216. Turns out that the 4th root of 1296 is 6. 6 cubed is 216. Okay? And this one you should be able to do in your head. Let's do the cube root of 11 to the 6th. Now, I would have no idea what 11 to the 6th power is. That's a lot going on. But if you make this into an exponent, what would the exponent be? It's 11 raised to the, remember the root is the bottom, so it's the 6 is the top, root is the bottom, so it's the 6/3. But what's 6/3? Just 2. This is 11 squared, and you should all be able to do 11 squared in your head. Answer is 121. Okay, let's get some more variables in these last couple. Let's do the cube root of 2x over y, all raised to the 5th. Now, if we're just following directions, directions said write as an expression with rational exponents. So I could just say 2x over y raised to what power? Hopefully you're thinking 5/3, root on the bottom. That could be fine. You can say that's your answer. It's short answer. Just realize this is the same as 2 to the 5/3, x to the 5/3 over y to the 5/3. because all of these have exponents of 1 on them right now. So when I distribute, they all just stay 5/3. Either of those were fine. Just realize that either could be a multiple choice answer. All right, last one, a little tricky. Make this an expression with rational exponents, xy times the cube root of x squared y squared. Well, the xy doesn't have any root or anything, so that's just going to stay out front. But this piece, we're having x squared y squared. What do you think the power on that would be? Well, there are powers inside here. They both happen to be 2's. The root is 3, so for sure the denominator is going to be 3. But technically, this whole inside is being raised to the first power. It's not being shown. So I just say the 1/3 initially, because I've already got the squareds in here. But then I would need to distribute the exponent. So this is xy times x to the 2/3, y to the 2/3. Am I done? No, because we can add exponents. These are really x to the first, y to the first. So this step, I'm going to add exponents. So the x's can combine. We can keep the base, 1 plus 2/3. Think of 1 as 3/3. So 3/3 plus 2/3, that's 5/3. So x to the 5/3, and the same thing's going to happen to the y's. Y to the 5/3. And there's your answer. Now, that is the same as xy, all raised to the 5/3 if that was a multiple choice. But either way would be acceptable. All right, we're done. So give your homework a shot. It's actually out of the book tonight. So do the best you can with it and be checking your answers. We'll continue some more of this in the next lesson. Good luck.